Trigonometry. Now, for a lot of us, that word alone can be a bit much, right? You're probably thinking of complicated formulas and just endless tables of numbers. But what if I told you that the heart of it, the real core of it, all comes down to just a few special angles? Angles that are actually way, way simpler to understand than you think.
So have you ever wondered why these three angles, 30, 45, and 60 degrees, seem to get all the love in trigonometry? What makes them so darn special? Well, I'll tell you, it is not random. There is a beautiful, elegant logic behind it, and today we're going to pull back the curtain and see exactly what it is. Okay, first up, let's build this thing from scratch. Instead of just trying to memorize a bunch of formulas, we're going to use some really simple geometry to see where these famous trigonometric ratios actually come from. Our whole adventure starts with one perfect, simple shape, an equilateral triangle. You know the one, all sides are equal and all the angles are a perfect 60 degrees. Believe it or not, this one shape holds the key to unlocking the secrets of both the 30 and 60-degree angles. So, how do we do it? It's a super simple four-step process. First, we take our beautiful equilateral triangle. Second, we slice it right down the middle. Poof! Now we have two identical right-angle triangles. Third, we use a tool you definitely already know, good old Pythagoras' theorem, to find the height. And finally, once we know all three sides, we can calculate the ratios. See? Simple. And here are the results. From that right-angled triangle we just made, we can zoom in on that 60-degree corner. We know sine is just the opposite side over the hypotenuse. That simple division gives us the square root of 3 over 2. Cosine gives us a nice clean 1/2. And the tangent is the square root of 3. No dark magic here, just pure, simple logic. But here is the best part. We don't even need a new shape to figure out 30 degrees. We just have to look at the other corner of the exact same triangle. Remember when we split that 60-degree angle at the very top? Well, that created a 30-degree angle. So one triangle gives us two sets of values basically for free. How efficient is that? All right, now for our next special angle. To unlock the secrets of 45 degrees, we need a different but just as neat shape, a right-angled isosceles triangle. This means two sides are equal, which also means two angles are equal. And since one angle is already 90 degrees, the other two have to be 45 degrees each. And when we use that same process, using Pythagoras to find the hypotenuse, we get these beautifully straightforward ratios. For 45 degrees, the sine and cosine are both 1 over the square root of 2. They're identical. And the tangent? It's just 1. So elegant and so easy to remember. So let's just pause and think about that for a second. Everything we've discovered, all those key values for 30, 45, and 60 degrees, comes from just two very basic triangles. That's it. That's the entire foundation. It's not some long, random list of numbers. It's all just clean, pure geometry. Okay, time for section 2. Your trigonometry toolkit. We've done the hard work of discovering the values. Now, let's assemble them into a master key that's going to let us solve all kinds of problems. And I really want you to think of this as more than just a chart you have to memorize. Think of it as the master key we just forged ourselves, our ultimate cheat sheet for standard angles. And here it is, the complete table. All the values for our standard angles, all the way from 0 to 90 degrees. This table right here is our toolkit. Anytime you see a sin 30 or a tan 45 in a problem, you just come here and look it up. We derived most of these from scratch, and the values for 0 and 90 degrees follow that same exact logic. But don't just stare at it like it's a random collection of numbers. Look for the patterns, because they're totally there. As the angle gets bigger, going from 0 to 90, the value for sine smoothly increases from 0 all the way up to 1. And at the exact same time, the cosine value does the complete opposite. It decreases from 1 all the way down to 0. They're like perfect mirror images of each other. It's a beautiful, built-in relationship. And that relationship is captured perfectly in one of the most important, most fundamental rules in all of trigonometry. Sine squared of an angle plus cosine squared of that same angle always equals 1. Go ahead, pick any angle from our table and try it. You'll see, it works every single time. It's kind of like the glue that holds this whole system together. All right, let's have some fun. Time to put our brand new toolkit to work. In this section, we're going to solve some puzzles and see how this master key turns what look like complex problems into pretty simple solutions. Take a look at this. At first glance, this expression looks like a total nightmare, right? You've got all these powers and functions. And by the way, that little squared symbol on the sign just means you find the value of sine 30 first, and then you square that number. Same idea for cubed and to the fourth. But here's the secret. This isn't a complex math problem at all. It's really just a substitution puzzle. All we have to do is go to our toolkit, grab the values we need, and just plug them in. We know sine 30 is a half, cos 60 is also a half, and tan 45 is 1. We just swap out the words for the numbers. And once you do the simple arithmetic, you square the first half, you cube the second half, and so on, that entire intimidating expression just boils down to one clean, satisfying number, 3. The toolkit makes it easy. Okay, let's try a different kind of puzzle. This time, we're not given the angle. The question is, find the value of a if the sine of 2a is equal to 1. So now we have to work backward. So here, we use our toolkit, but we use it in reverse. We look at our table, and we ask ourselves the question, the sine of what angle equals 1? A quick look shows us the answer is 90 degrees. So if the sine of 2a is the same as the sine of 90, well then, 2a must equal 90 degrees. And if 2a is 90, then a little bit of simple division gives us our final answer. A is 45 degrees. See? The toolkit works both ways. It helps us find values, and it helps us find angles. It is an incredibly powerful tool. So we've built the tools, we've solved some puzzles. But you might be asking yourself, okay, but why does any of this actually matter? Well, in our final section, let's look beyond the textbook and see how this connects to the real world. Because these are not just abstract numbers on a page. These standard angles and the ratios that come from them are literally the fundamental building blocks for the world all around us. They are absolutely essential in engineering to calculate forces, in physics to understand waves, and even in computer graphics to render the 3D worlds you see in movies and video games. So the next time you see a towering bridge or you play a video game with incredible graphics, just remember the two simple triangles that make it all possible. These angles help build our world. So the only question left is, what will